Alright, today we'll move on to the subtopic of kinetic energy, something that you are already very familiar with. Kinetic energy equation is half mv squared. I think you know this very well, where m is the mass and v is the speed. If a car of 1000 kg moving at 10 meter per second, kinetic energy is 50 kilojoule, and if it has 30 meter per second, then it will become 450 kilojoule. Okay, in L level you need to know how to derive this equation of kinetic energy. So let's look at the case here. We have an object of mass m is being acted on by a constant force F, so that it accelerates from u to v through a distance s. So from v squared equals u squared plus 2as, we can use this because it's uniform acceleration. We have m added on to every single term of them. So you look at the m added on to every single term of them, so that is mathematically correct. Then we shift the MAS to become the subject in front. MAS equals to half mv squared minus half mu squared. So you can see something already now, that the work done is F times displacement, force times displacement. Therefore the F there is a net force in this case, which is expanded into MA. So F expanded into MA. So MAS, which is in the equation just now, if we sub in, then we shall get actually the MAS is force times distance, and it is work done. So we have work done equals to half mv squared minus half mu squared, the final velocity, final kinetic energy, minus the initial kinetic energy. Alright, so as you do some work on something and it increase in its kinetic energy but not other forms like potential energy, then we shall say that the work done causes the change in the kinetic energy. The work done causes the increase in the kinetic energy. Alright, you must know how to derive this, yeah? So let's move on. So that's added on to that. Net work done equals to change in kinetic energy. So we have one example here. Horizontal force of 90 Newton push a box across the horizontal floor. Frictional force is 50, so we can draw that. Frictional force is 50 and forward force is 90 Newton. Okay, so that's the ground with some friction. Work done by the horizontal force, so it is moved 6 meter forward, 6 meter forward. Alright, work done by the horizontal force, which is the 90 Newton, so you should use 90 Newton times 6. So 90 times 6, you get the answer. Then work done against the frictional force. So I think inside your worksheet is written as work done by. Please change it to against as a typo. Work done against the frictional force. Done against the frictional force. So we have the frictional force as 50 Newton. So 50 Newton times 6. So basically is 300. And net work done on the box. So net work done on the box will be the 90 Newton of work done. I mean the work done by 90 Newton and minus the work done by the horizontal force minus the work done by the frictional force. Then you should get the net work done on the box. Okay, so change in kinetic energy of the box. So remember, if there's no other types of change of energy, and this will cause only the increase in the kinetic energy, because we see that 90 Newton is bigger than 50 Newton and its work done is more, and therefore that is the answer that will be same as part C. Okay, So next question, we have speed of a dog sleigh, 80 kg, moving along a horizontal ground, increase from 3 to 9 meter per second over a distance of 90 Newton. So this is the final speed, this is the initial speed. Okay, distance is 90. Find the increase in kinetic energy of the sleigh. So increase in kinetic energy, very simple, final minus initial. Okay, so you sub in the half mv squared of 9 meter per second minus the half mv squared of 3 meter per second. You should be able to get the answer. The force exerted on the sleigh by the dog, assuming that there's no resistance. Okay, so which means that this kinetic energy, increase in the kinetic energy, must be caused by this net force of the dog. So we say work done equals to the change in KE, and the force will be just the force inside the equation of work done will be just the force by the dog, because that's the net force. So it causes the distance of 90 meter. So you use your answer from A, you sub in the 90, then that force should be the force exerted by the dog, okay, because without air resistance or frictional force. So next one, that will be your assignment question, okay, and we'll move on to potential energy. Okay, something that you're also quite familiar, but let me explain that one more time. So for example, gravitational potential energy, if you shift the position where it wants to be naturally, then it should gain gravitational potential energy in this case here, therefore it will fall later. Other cases are like springs, elastical potential energy. This is GPE just now. This is the elastical potential energy, elastic potential energy. The one on top here is magnetic potential energy, but we are not going to look at that actually. And we have electrical potential energy. Okay, so positive charge and negative charge, supposedly this is the condition or position that they want to be. If you shift the two charge away from each other, you try to split them, so they will want to get back together. Therefore, when you split them, they will have a gain in the potential energy. All right, so the spring here, elastic potential energy, if you have a spring that you try to stretch that from its equilibrium position, then it will have a gain in the elastic potential energy. And spring also will have elastic potential energy when you compress them. So that's slightly different from the gravitational potential energy, where there's only one condition, whereas for spring or elastic stuffs, you actually can give them elastical potential energy by compressing or extending. So it has two situations where they can gain the elastical potential energy. Okay, so that's potential energy. Right, so we need to know how to derive the gravitational potential energy particularly, right? And let's say we have a case here, object is raised to a height of h2, so there's a h2, let's say ground is h1. Okay, so from h1 to h2 without any change in the kinetic energy. Okay, no change in the speed, so you're like lifting it up or pushing it up very slowly. Okay, so work done will be force times displacement. So no matter you are trying to lift it up vertically like this guy here, or you're trying to push it up through an inclined plane, the F and also the S, the corresponding S, will give you the same answer as long as you increase by the same height. Okay, doesn't matter about the direction of motion, and as long as they achieve the same height at the end. Okay, so force apply must be equal to the weight of the object. I think I explained this in the previous case of the forklift. Okay, if you are not accelerating it, then your force upward must be equal, at least equal to the force downward, and therefore F equals to mg, okay, equals to the weight. Okay, so work done is mg times h2 minus h1. So we actually have changed the F into mg, and we change S into h2 minus h1. Okay, then we'll see that is actually mgh2 minus mgh1. Just like how we derived the kinetic energy just now, this part become the final gravitational potential energy, this part become the initial gravitational potential energy, and if you look at that, it's actually a change in the potential energy. So we say work done equals to change in potential energy. So by now you can see very clearly that work done actually is related very closely to energy, and basically it has the same unit as the energy. Okay, so we have derived that earlier actually regarding the base unit. Okay, so we have one example here. The pump lifts water from the lake to a large tank of 20 meter above the lake. How much work does the pump do as it transfer 5 meter cube of water to the tank? Okay, so it's trying to lift the water up by 20 meter. It's pumping it. Okay, so and we are given 1 meter cube is 1000, so 5 meter cube is 5000 kg. Okay, so the mass of the water being lifted up is 5000 kg, and therefore work done will be at least equal to the weight, that's the F, times the distance moved, that's the 20 meter. Then you should be able to get the answer, and this answer here will be actually same as the change in the gravitational potential energy of the water lifted up. Alright, so we'll stop here.